In this video, we're going to learn about what is demand-driven MRP, and in the next couple of videos, we'll see practically how it really works on the S/4HANA system. So the topics we'll be covering, they are what is DDMRP, methodology in DDMRP, history of DDMRP, what are the products that are relevant to this demand-driven MRP, components of DDMRP, DDMRP apps available in S/4HANA system, and decoupled lead time. So first of all, let us start with what is DDMRP. In simple words, DDMRP is a new MRP type called D1, and it's similar like the other MRP types we have like PD, ND, VB in the existing system, or in the EC system you can also find this PD, VB MRP types. But this new MRP type D1 is not only available in the S/4HANA system from the 1709 version. This MRP type will consider not only demand but a lot of different factors that we'll be discussing in this lecture. Now, before we try to understand more about the what is DDMRP and why we need it, before that, let us discuss what are the limitations of the existing MRP type like PD, VB, etc. So let us discuss just these two of them. So let's discuss the most commonly used one MRP type, which is PD. So this is basically a demand-based MRP type. So MRP type PD works mainly on forecast, and from the forecast demand is generated that we can see in the MRP transactions like MDO4, MDO6, etc. But in the real-time environment, the average forecast accuracy is about 50 to 60%, or maximum in an ideal situation probably 70 to 80%. But this is the most common average forecast accuracy in a real-time business. Forecast inaccuracy causes either the excessive inventory or there can be material shortages. Changes in the demand upstream have an increasing ripple effect downstream. So what that means is, for example, if you look at this bill of material for a bike, so this bike is made from say frame assembly and then wheels, and at the bottom level there is another raw material, say tire rims. So if a company is making different types of bikes and this tire rim is used not only in this BOM but in a lot of different other BOMs for different bikes. So if there is an inaccuracy in the forecast at bike level, so what will happen? It will also change the inaccuracy of the raw material level, which is the tire rims. Now if we have inaccuracy at this bike 1, then think about the inaccuracy in bike 2, bike 3, bike 4, and so on. So if these tire rims are used in different BOMs, in say hundreds of different other BOMs, then think about if all the top level code are having inaccuracy in the forecast, then what will happen about the stock level at the tire rims at the raw material level. So because of the inaccuracy in the different finished goods level, either we can have an excessive stock for tire rims or either we can run out of the stock. So that's the main issue with this MRP type PD. Now we'll also check another most commonly used MRP type, which is VB, also known as reorder point planning. So this is, as the name is saying, this is basically the reorder based planning. So basically what happens is we maintain a reorder point and we also have a safety stock level and also a maximum stock level. So just say in this example, so we got say safety stock 100 and say reorder point is 200 and say stock level is 500. Now whenever the stock falls below reorder point, just say around 200, then system will be generating requirement and procurement will start. And by the time the stock level reaches the safety stock level, we'll have the procurement done, and the stock will be then filled up to this maximum stock level, which is 500. And So let's see what are the limitations with this type of MRP. So this MRP type also can't accommodate the fluctuation in demand. So it will only follow this pattern of the reorder point according to the safety stock and the maximum stock level, but it can't accommodate the fluctuation in the demand. Demand spikes won't work. So what demand spike means, for example, if your product, if say in this example, if we got the maximum stock level of 500 and say we receive a sales order for say 5,000, or we got a requirement from, say it's a raw material used in a production order, and we received another requirement from the production order for say 5,000 quantity, then system will be again on generating the proposal for 500 only as per this setup. It can't consider the big spike change or the demand spike for 5,000. So that's what I mean here, is that demand spike won't work in this case. So again, this MRP has these limitations. Now that's where this one comes into picture, where the DDMRP can handle all this. So we'll see in this video and next video as well that how it really helps the business to have the best level of inventory in the business. So let us understand first what is DDMRP. It is very important for a business to maintain the correct stock levels for the critical products. Too many materials will end up with excessive inventory, and not buffering enough materials may lead to material shortages and longer lead times. To overcome this issue, a new MRP type D1 was launched in S4 HANA 1709 version. In DDMRP, buffers are maintained at different level of supply chain known as decoupling points. So what decoupling point means, so if you see this picture on the left hand side, you can see a normal MRP explosion. You can see this is a bomb levels, different bomb levels for material. But what happens in the decoupling points, what happens is on the right hand side you can see this colorful one. So these are the buffering points. So that means we create the buffer at this level. So for example, this is semi-finished good, this is another semi-finished good. At the bottom these are maybe raw materials. So at these levels we always create a buffer or always create a stock. So that means we never run out of it, the stock for these codes as well. So we maintain the stocks at these levels, and DDMRP will look after them at these levels and will maintain the best level of stock that is required as per the different criteria. For example, demand spikes, or maybe change in the forecast, or as per the history, etc. So we'll see in more detail soon in a minute. So that's what it means, is these are known as the decoupling points. That means we're maintaining the buffer at different levels, rather than only traditionally we maintain the buffer at this top level only, probably. So we'll discuss in a minute in more details. Now let us understand more theoretical side of it first. So DDMRP is a part of MRP. SAP S4 HANA introduces the concept of demand-driven replenishment, or DDMRP, to offer new tools to help organization manage their stock levels at the optimal level. Demand-driven replenishment provides the ability to classify the products according to the demand history. DDMRP decouples the flow of semi-finished goods at strategic steps of the supply chain by stabilizing dynamic material buffers, like we have just seen in the last slide. And these buffers smooth any fluctuation in the material demand. DDMRP ensures high SLAs while keeping the inventory low. New MRP type D1 is a modification of the traditional MRP type VB. So that's what DDMRP is. Now we'll talk about the methodology in the DDMRP. Now if you look at this picture, as we discussed earlier, that we maintain the buffers or stock levels at different points, at basically the critical points, you can see. Now with the strategy we use, or sorry, the methodology we use here, is we need to identify where to stock, how much to stock, and then this is all we have different apps available in S4 HANA that will tell us where to stock, how much we need to stock, and then we can also see the dynamic review. Then also the generation of the supply orders according to the average daily usage plus qualified sales spike. So system will be on a daily basis, system will be checking the average daily usage, and then will consider the demand spike or the sales spike. To guide and alert execution in a visual manner. So that again different apps available that can guide you for any in a visual manner for any changes or any alert or any modification. For example, system can propose you that okay, for example, here we need to change the safety stock, or here we need to increase the stock or safety stock levels, or here we need to decrease the safety stock levels. So all these functionality are available in the system that we'll see in the later videos. Now let us look at the DDMRP history. So basically MRP, as we know that MRP is not a SAP only tool. So MRP was basically was launched in 1960, long time before SAP was introduced. So in 1960 a traditional MRP was used, and then in 1970 they came up with another version called closed loop MRP. Then in 1980 MRP2 was launched, and finally in 1990 MRP in the ERP system was launched, and in 2011 we have the DDMRP functionality available. Now this DDMRP, as I said, is a third-party tool, you can say, and now available in our S4 HANA system starting from 1709 version. There's a book if you want to understand more about it. This book is available on the Amazon website. You can check, and or also you can visit their website demand-driven-institute.com to understand more about DDMRP in general, not from SAP perspective, in general perspective. Now we'll talk about what are the products relevant to DDMRP. That means how do we identify what products we should be maintaining as DDMRP relevant. So the first point is high variability. That means demand fluctuation. So those products where is a fluctuation in the demand, there sometimes probably there's a huge sales order, or sometimes there's a for some months there can be very low orders, and some months can be very high orders. So when there's a demand fluctuation and we are unsure about the forecast, and for those material, this DDMRP needs to be activated. Second main factor is the high usability. High usability means that in how many BOMs this item is used. For example, if you look at this picture here you can see on the top you have finished goods, at the bottom you have raw material 1, raw material 2. Now this raw material 2 can be used in maybe hundreds of different BOMs, other BOMs, and raw material 1 can also be used in thousands of different other BOMs. So this DDMRP functionality is relevant for those products that are having high usability. So these are actually one of the important questions for interview as well. If you're going for interview, they might ask you that okay, what are the products relevant for DDMRP? So you can answer that okay, for those where there's demand fluctuation and also the high usability. Now we'll discuss components of DDMRP. Now there are some components defined by the Demand-Driven Institute, the website that I just talked before, and these are the standard components defined by them and also available in the S4 HANA system. We'll talk about the tools available in the S4 HANA system in a minute, but let us discuss about the standard components defined by the Demand-Driven Institute. So first one is a classification tool. First of all, we need to classify the products. So these products are classified based on the consumption, their BOM usage, and variability. So again, we'll see all of these practically in the later videos. How we do that, we'll discuss later. Second component is mass maintenance of product, where you can mass maintain. For example, you can change the MRP type, you can change different MRP factors as a mass. So we also have some tools available, some apps available that we'll discuss later on. Automatic buffer proposal calculation, schedule decoupled lead time classification of products, tools or apps to monitor the buffer levels, and that's all. Now all these 5 steps we'll see practically later on, and we'll discuss in more details. Now from our S/4HANA system perspective, we'll discuss what are the DDMRP apps available. Now under there's a tile group called demand driven replenishment. Under that you can see a couple of different apps available. Now these apps, for example, this schedule product classification, mass maintenance of products, schedule lead time classification of products, and schedule buffer proposal calculation are basically the configuration apps. And other apps you can see here, they are basically the operational apps. Now the steps that I have just discussed in the previous slide, these ones, so these steps are basically a part of mainly these configuration apps and also some operational apps. So we'll start with, we'll see later on in the later video though how we can start with the schedule product classification, then we can move on to the mass maintenance. So we'll see that step by step in the later videos. And the other apps are basically, there are the operation level apps. Now in a real-time environment, either the super user or the support or the consultant, they have the access to these configuration apps, and all the end users, they use these operational apps basically. So let me show you this one on the S/4HANA system as well. So here, if I search for a tile group, this one you can see demand driven replenishment. So here you can see different apps that I was just showing you. So these, some apps are 1, 2, 3, 4. These apps are configuration app, and other apps are basically the operation level apps. So we'll discuss more in the next videos about this one. And these are basically available under the business roles that I have mentioned at the bottom. Now we'll discuss here the operational apps and also this buffer levels. Now here you can see on the left hand side the configuration and setup apps. So step by step we go through these apps. So first step is to schedule product classification, second step is to mass maintenance product, and then third is the schedule lead time classification, and the last one is the schedule buffer proposal calculation. And once it's set up, then there are some operational apps to monitor them. For example, these are the manage buffer levels, replenishment planning, replenishment execution. Now we'll discuss again, as I said before, in the next videos how we can use these apps step by step later on. Now here I want to show you, if you look at the picture on the right hand side here, I want to show you the different buffer levels that is maintained by the DDMRP function. So here system will be automatically maintaining different buffer levels. So buffer levels are basically divided into, you can see that 5 different colors. So at the bottom you got the red safety, which is the minimum safety stock. Then you got the red base, which is the safety stock. Then you got the yellow one, where that's another stock level, which is a reorder point level, and green one is a maximum stock level. So basically there are 4 colors, it's showing 5, but they are basically 4 colors only, starting from green, yellow, red base, and red safety. Now this how system is calculating, we again discuss later on more details, but in briefly here what happens is system will be first calculating the yellow point. For example, system will be dynamically on the daily basis, it will be calculating the reorder point. So like in the traditional MRP, if you use other MRPs like PD and all that, or if you use, say for example, VB, which is a reorder point planning, once you have maintained the reorder point, it's not dynamic basically. So Here it's dynamic. So system will be first calculating the reorder point, which is the yellow area. So how does system calculate this is basically the depending on the average daily usage. So we can tell the system that, okay, look back for the average daily usage in the last 30 days. We can say look back in the last 60 days, 90 days, 180 days, whatever you want. So system will be looking back into those specific days that we have mentioned in the system, and system will be calculating the daily average usage accordingly. And that daily average usage will be multiplied by the decoupled lead time. Now what is decoupled lead time? That I'll discuss in the next slide after this one. So system first calculate this yellow point, which is a reorder point, and then system will be calculating the red base, which is a safety point, safety stock. So safety stock will be yellow, whatever the yellow says. For example, the result for the reorder point is 50. So system will be considering that 50 multiplied by the lead time factor, that will calculate the safety stock. Now what is lead time factor? We'll discuss in the next video. And once the safety stock is done, system will be calculating the minimum safety stock, which is the formula here is red base. This is a red base multiplied by the variability factor. So whatever the red base is, for example, red base is say 30, then 30 multiplied by the variability factor. Again, variability factor we'll discuss in the next video. And then finally system will be calculating the maximum stock, which is the green level. So the green area, which is the maximum stock, is maximum of either of them, either three of them. For example, system will be using the yellow zone, whatever the yellow is, multiply the lead time factor. So lead time factor we'll discuss later on. So either this or minimum orders quantity or average daily usage multiplied by the order cycle. So out of these three, whatever the maximum is, system will be considering that value only to calculate the green level. So here you can see system will be dynamically on daily basis calculating the reorder point, safety stock level, minimum safety stock level, and also the maximum stock as well. So we'll do some practical in the next videos. Now let us understand about the what is decoupled lead time. So as you can see in this buffer level calculation, system is using a decoupled lead time here for calculating the yellow zone, yellow area, which is the reorder point. So let us discuss what is decoupled lead time. So if you look at this picture here, this is showing you the coupled lead time. Basically, say we want to make say this one from raw stock, we're maintaining some semi-finished goods. Further, there are some function, some operations, and then finally going to assembly, then painting, configure, and going to customer. So this is a typical coupled lead time. For example, starting from the raw material up to the finished goods is taking say 8 weeks time, which is a coupled lead system lead time is 8 weeks. But what happens is once we maintain the decoupling points, for example, we maintain the stock level here, we maintain the stock level here, 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 here. So system is calculating all those areas, the green one, yellow one, red ones, at all these levels. For example, here we got finished product, here you got semi-finished product. At the beginning you got the raw material. So wherever you have activated the DDMRP MRP type, system will be calculating the different buffer levels, green, yellow, and red one at those levels. Let me fix it at those levels. So in this one you can notice on the top that lead time now is different. Now lead time, before it was total lead time was 8 weeks. Now lead time is broken. So you can see in the beginning lead time is 4 weeks to get the raw material, for example, and then from this operation to the middle of this operation the lead time is 3 weeks, and the last one the lead time is 1 week. So lead time is broken from 8 weeks to 4 weeks, 3 weeks, and 1 week. So that's called decoupled lead time calculation. But how the system is really calculating, that we'll discuss in the next slide here. So okay, let's look at this example one. So decoupled lead time, you can see, for example, here you have a product called FPB. It's made from different semi-finished goods, say SAA, SAL, and there are further semi-finished goods semi-finished goods, and at the bottom maybe the raw materials. Now here you can see there are two legs for this one. So FAB is maintained from SAA and also SAL, and they further have further BOMs. Now system is calculating the decoupled lead time as the longest lead time, whether on the left hand side, whether on the right hand side. For example, here you can see the yellow points. Anything which is yellow, system is considering that as the total lead time, because this is the longest path. For example, if you look at the right hand side, if you see the longest lead time, so you can see 1 plus 2 is 3, and not 7, will consider 9, which is the longest. So 9 and 3 is 12 days on right hand side. But on left hand side you can see 1 and 3 and 3 6, 6 and 2 8, 8 and 8, which is 16. So system will be, in this case for this product FPB, system will be considering the decoupled lead time as 16, because this is the longest lead time. So that's example 1. Let's take another example. Say this one is a very simple example. So on the top you have finished goods, which is taking 5 days lead time. Then you got semi-finished good 1. Then you got raw material 1 at the bottom. Now 5 days, 10 days, 15 days. So the total lead time here will be 5, 10, 15, and another 15 will be 30 days lead time. But if we buffer material at this level, that means at the raw material level, if we activate the DDMRP for this product, then system will be always thinking that at this level stock is always available. Okay, so it will ignore the 15 days and think that stock is always available here. Now the decoupled lead time for finished goods will be only 5 and 10, that means 15. So before, let me show you previous slide, before it was 30. Now because we have activated the buffering or the DDMRP at the bottom level, now system is thinking that we always have the stock available here. So now the lead time for finished good level will be not 30, it will be 5 and 10, which is 15. Let's take another example here. So you got finished goods, semi-finished good 1, semi-finished good 2, and semi-finished good is further made from raw material, semi-finished good 3, raw material 4, raw material 5, and same on the right hand side, raw material 1, raw material 2 are used for semi-finished good 2. Now if we calculate the longest lead time, so let's see, on the right hand side it's 5 in 10, 15, and then another 15, which is 30. On left hand side we got 5 and 5, 10, and 10 is 20, 20 and 12 will be 32. So because 32, system will be considering 32 because that's the longest path on the left hand side, it will be ignoring the lead time on the right hand side. So for finished good 1, the decoupled lead time is 32 days. Now if we maintain this material RM4 as a buffered material, or we activate the DDMRP for this one, then system will be ignoring this and thinking that okay, we always have stock available here, so these 12 days will be ignored. System thinks always stock is there. Now decoupled lead time will be on left hand side. Now again system will be calculating decoupled lead time. So here you have 5 and 5, 10, and 10, 20, and 25 on left hand side. Now on right hand side you got 5 and 10, 15, and 15, 13. Now the decoupled lead time on the right hand side is longer, which is 30 days now. So system will be now considering 30 days from the right hand side. If you also maintain this raw material 1 as buffered material, again system will think there is always stock available here. Now system will again recalculate the decoupled lead time. So this time it will be on the right hand side, it will be 5 and 10, 15, and then 10 it will be 25. On the left hand side it will be 5 and 5, 10, 10 and 10, 20, and 7, 27. So 27 is longer than 25. System will be considering this 27 days from left hand side. So that's how the decoupled lead time is calculated on the daily basis. And accordingly, as I have shown you before the previous slide, let me show you this one. And accordingly, system will be calculating the stock on the daily basis for this one. So on daily basis, as per the decoupled lead time and also as per the average daily usage for the say last 30 days or last 60 days, whatever you have set up, system will be calculating the daily stock levels. So that's how the decoupled lead time is calculated. So that's all about this video. In the next video, we'll do some practical and we'll see how it really, I'll show you how it really works step by step in the S/4HANA system. And just a recap, now we learned about what is DDMRP, methodology in DDMRP, DDMRP history, products relevant to DDMRP, components of DDMRP, DDMRP apps available in S/4HANA system, and what is decoupled lead time and how it is calculated. So that's all about this, and thank you very much to watch this.